Okay, just give you a little historical perspective. Certainly, modern textbooks, some of them have really good problems, but they tend to, put them in the problems plus section where no one ever touches. Whereas, like in Wells's text, the problem pluses really start with the initial problems. They're more difficult. There's no doubt about it. He doesn't give trivial problems. But what I notice about modern textbooks, they tend to put a lot of trivial problems up front, and then they say, okay, yeah, if you're a really good student, maybe you can do the problem pluses later. All right. But when I'm looking at this one over here, and I got to be honest with you, if A were equal to B, were equal to C, were zero, that this thing over here would give you 0 equals 0 for all x, by the way. So what I'm going to do is I'm going to just say I don't want that to occur, right? Otherwise, it would be a really simple equation, by the way. What do you get? You would get root of 0, regardless of what x is, root of 0, regardless of what x is, and that would be the root of 0. Again, regardless of what x is, and that's certainly true. So I'm not kind of interested in that. So I'm gonna proceed forward as if a, b, and c were not equal to 0. And what I'm going to do, I'm going to square both sides. And I'm getting a little better. So I'm going to say it's going to be ax plus bc. Whoops, I didn't mean to do that. And then it's going to be plus ax minus bc. Let's see, then it's going to be plus 2 the root of ax. I'm just using the binomial theorem, by the way. And ax minus bc. In other words, I'm expanding a binomial with degree 2. I'm squaring both sides. And what do you get on the right side? Well, you get 4ax minus 2bc. Well, I'm going to go through things that I see disappearing immediately. And let me point this out to you. The bc disappears, all right? And then what I'm going to do is I'm going to kind of concentrate on the ax in the problem. And if I did that, 2ax on the left, 4ax on the right, I would probably subtract 2ax from both sides, and I would get 2ax. So I'm going to claim everything has been accounted for here. All right? Then what do you get? Minus 2bc. And what do you get over here? Well, you get 2, and then you get the root of ax plus bc. I think I went too far with the radical there. And another radical of ax minus bc. I'm going to divide by 2. And what do you get? Well, you get this. You get ax plus bc, ax minus bc equals ax minus bc. Hope I didn't go too fast with that, dividing by 2. Now I'm going to do square both sides. And what do you get? ax plus bc, ax minus bc equals ax minus bc quantity squared. Or I'm going to do something a little differently. I know over here, I certainly see that line over there, but I'm not going to do this part. I'm going to do a little differently. I'm going to write it as a zero product rule. So ax plus bc times ax minus bc minus ax minus bc squared equals 0. I'm going to factor that. And what do I factor out? ax minus bc. And what am I left off with? I'll write that down for you. Let's see. You're left off with ax plus bc minus, we only pulled out one of the factors, so I'm left off with, subtract ax minus bc. So minus ax plus bc equals 0. And I'll keep going for it. What do you get? ax minus bc. And then what do you have there? Well, this disappears, and you get 2bc. That equals 0. The only way this could be equal to 0 is if B and C were 0. But I said in the beginning, I'm not gonna have that. The other case would be, does ax minus bc equal 0? And that looks relatively simple to solve, by the way. And what's that going to be? X equals bc over a. And remember, a, b, and c are not 0 in the problem. So that's fine. So the question is it a solution to the problem? And so I'm going to write that down. I'm going to say, I wonder, is x equal bc over a an answer to this question? And let's just take a look. I don't know. All right. So I'm gonna put it in. And what would you get there if you plugged it in? You get BC plus BC, which is 2BC, plus, what do you get there? You would get BC minus BC, which is 0. What do you get over here? Let's see, you would get 4BC minus 2BCs, which is root of 2BC. All right? Seemed to work out pretty nice, by the way. I'm getting it. All right? I'm getting it. This has certainly satisfied the original equation. All right? So this is good. All right? Okay. That was tough, though. I would say a problem plus. All right? Thank you.